Okay, so today we're actually going to be talking about accuracy and precision, which they are not the same thing. So in chemistry, we've been talking about we make a lot of measurements to study and understand things, and so we've got to make sure that accuracy and precision in those measurements is on point. So accurate versus precise, what is the difference? It can be confusing at first. A measurement can be precise, or it can be accurate, or it can be both, or it can be neither. And these terms can refer to either multiple repeated measurements or just one individual measurement. So, side note, as scientists who are legit scientists working in the labs collecting data, they are not going to just run an experiment one time and be like, yep, those results are good. They're going to run it many times to prove that that first run through was in fact a correct representation of what they were trying to get. If they start seeing that they're not getting the same thing every time, that's evidence of not being a good scientist and lack of precision and accuracy. So you'll never see somebody just attempt in science something once and assume things are good. That's why we take multiple measurements. Anyway, I got way off topic. Here we go. Precision is the degree of exactness to which a measurement can be reproduced. That means repeated. So when I'm talking about precision, I'm focusing on many different measurements on the same thing at the same time. So precision is limited by the smallest division on a measuring tool. The smallest division, for example, on a meter stick is a millimeter. And y'all, you are not going to believe it. I was not prepared for this, but I have a ruler here. Oh my gosh, it's this tiny ruler, so it's kind of, this is very frustrating to look at. So if I were to look at this side, which I'm not looking at this side because this is inches, and we are scientists and we are doing metric systems, so here we go. So if I were to look at this side, I notice that I've got some tick marks here. And those tick marks actually help me measure things, okay? Now, the number of tick marks or how exact each one of those values are is going to help me have a little bit more confidence in what measurement I'm going to define something as. In my volume things, I was prepared for these items because, believe it or not, I am actively trying to brainwash my own children to becoming scientists. And so here I have a beaker. They have these things called, well, the science term is called graduations, but they are tick marks, and they're helping me kind of understand, if I were to fill up this beaker, where I am in terms of milliliters of volume of the substance that I'm measuring. We also have, we love these, graduated cylinders in all shapes and sizes. Woo, that's really difficult to see. We don't need to care about that right now, but they've got those graduations, those tick marks. So that helps with precision. We're going to talk more about measuring with the tick marks, which y'all gonna love, so get excited. Woo. Okay, accuracy. Accuracy is the extent to which a measurement or a group of data agrees with an accepted value. The accepted value is a fancy word for like, what is the actual real answer? So with the real answer. Accuracy is usually indicated by a percent error calculation to measure how off you are from that real answer. We are not going to really focus on that, I think, not for a bit. Don't quote me on that. But that's what accuracy and precision is. So I'm actually going to jump down here. Sometimes Sabaka tries to make some of these sciencey definitions of accuracy and precision a little bit more friendly for, my simple brain at least. So in simple terms, accuracy is how close you are to getting the correct answer. What is the correct answer? Are you hitting it? And precision is how often repeated, notice I wrote repeated in italics. You need multiple attempts at measuring. That's how you measure precision. How often repeated measurements show the same answer. Notice I wrote same, not correct. You can be a precise scientist and not be getting the right answer, as long as all of the measurements are close together, which is wackadoo. Let's look at this with the target examples up here. And I just noticed I did not label these target A, so we're going to do that right now. B, C, D. Okay. So it can be compared, accuracy and precision, to like, let's pretend you're an archer and you are firing your arrows at a target. So here is my first target attempt. So it says for target A, all 3 shots are scattered and are not even near that bullseye. Okay, that bullseye is like what we want to get. That bullseye represents the correct answer that I'm looking for accuracy for. So we are not accurate because we didn't hit the bullseye, right? We didn't get the correct answer. But we are also not precise because all of these shot attempts are not close together. They're not the same, okay? So this is an example of a data set being not accurate and not precise. Okay. For number B, it says the shots are scattered apart. We don't like that for precision. However, if I were to average them all together, they roughly are around that correct spot. So we would call that actually accurate. Now, this is not a very common thing to happen. If I were to collect data like this as a scientist, there is probably not one real scientist out there who'd be like, yep, she's accurate. Accuracy is usually wanting to be followed with some amount of precision, but if you are not precise and you're trying to estimate accuracy, you're going to kind of have to average all those scattered precision measurements or not precise measurements into what, or average them all and to figure out if that average of all of them is close to the accepted or actual answer. Cool. All right, so that's accurate because of the average is hitting the target, but not because we are scattered. We don't like that. Okay. For targets, the shots are now relatively close together, but not near the bullseye. Okay. We are really close together. So that's precision, you guys. So we would say it's precise. But all of those guys, and we can even think about it as like the average of all of those guys, which is a little bit easier to understand because they're close together. We can kind of interpret more easily where that average location is. Not there. Right? So we are not accurate. And then finally, choice D is, we love that. All three shots, boom, 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 landed in the bullseye region. Therefore, these shots are precise. Yeah, because they're close together. And they are also accurate because they are hitting the target. They're getting that correct answer. Yes, so accurate and precise for this last example. Cute. So that's the definitions of accurate and precise. Now we're going to get into, well, how do we measure precision when we use our measuring instruments in science? Okay. Oh, all right. Here's some super sciencey words coming up. It says, measuring precisely. The numbers reported in a measurement are limited by the measuring tool. Significant figures, which are the numbers that are written down from a measurement, include known digits determined by the markings of the measuring instrument plus one estimated digit completely determined by the scientist. I'm like, what does all that mean? Yikes. Okay, so let's talk just kind of about what makes a precise instrument or not. I showed you guys a beaker here, right? And a precise measurement is going to require some help from these tick marks. If I notice I have here's the tick mark to represent 10 milliliters, and up here is 20, right? So that must mean this middle tick mark represents half of that, right? So that's going to be 15, right? So I can say that there's a tick mark for every, so if this 10, 15, 20, 25, 30, 35, 40, I'm counting by fives. So there's a tick mark for every 5 milliliters. Now compare this guy to a bigger beaker, which is super dirty because I don't know where this has been recently. Thanks, children. I've got a different kind of scale here, right? I see a 50 here and a 100 up here. The halfway point between 50 and 100 is 25, right? Or 75, which means I'm going 50 to 75 to 100 to 125 to 150. So this beaker has a tick mark for every 25 milliliters. This beaker has a tick mark for every 5 milliliters. So if I were to ask you, okay, go grab something to measure out 35 milliliters, which one are you going to use? Probably the one that gives you a little bit more confidence of, I'm pretty sure that's closer to 35. It's going to be this one, the one with the smaller graduations or the smallest spaces in between the measured value tick marks, right? It'd be much easier for me to estimate, 35. Oh, in fact, there's a tick mark exactly to 35, right? Versus this one, I'm like, great. I know that one is 25 and that one up there is 50, but there's a lot of room for error there as a scientist when I'm measuring things. So the instrument that you're using helps figure out the precision of the value that you're trying to measure with, right? So this is probably going to be the more precise measurement. So we're going to talk a little bit more on precisions of measuring tools, but let's talk about how to write down measurements as determined by the tick marks. Okay, I'm going to zoom in. I feel like that's going to be a terrible idea because last time I did that, it got real blurry. We're going to see. Okay, it's not terrible. It's not terrible. Regardless if it's blurry, I am so sorry. Luckily, you have your own handout in front of you that you can read from too. Okay. Now, first one, our first example here, this is a visual cartoon drawing of a graduated cylinder. Hopefully you have learned from science classes before that most liquids will do this funny thing inside of a graduated cylinder where they create what's called a meniscus, okay, where they stick kind of to the outsides of the graduated cylinder and there's this dip down concave shape at the bottom. So I should have written this in typed out notes, but I feel like every year I always have to write this, but here we go again. You've probably not heard this for the first time today, but when we read the volume from a graduated cylinder, we're reading from the bottom of that meniscus. So we're going to write that in. Read from the bottom of the meniscus. Okay, meniscus. That looks right to me. Cool. Yeah, so we're going to read from the bottom. So when it comes to looking at this value, I am going to, I have a ruler, so I will be using a ruler. This may end up looking terrible, but a ruler gives me a nice straight edge if I wanted to. Right. So we're looking right here. Okay. Hope that helped a little bit. Cool. Okay. So the first thing I'm looking at, I need to figure out what these tick marks are supposed to represent to me. I see actual numbers written on here. That is great. We're starting here. We have a 35 down here on this really big dark line that goes all the way across and a 40. And then in between here, we've got several tick marks. 1, 2, 3, 4. So if I were to look, that means this goes 35, 36, 37, 38, 39, and 40. So our tick marks are in increments of 1 milliliter, okay? So when I wrote down this measurement, because my tick marks are every 1 milliliter, I was able with confidence to say, hey, I'm sure the first number I'm writing down is a 3. You are real sure about that. It is not a 20-something. It is not a 50-something. You've got that water in between something that you can even visually read numerically, 40 and 35. So you're going to be pretty sure that that's a 3, right? Now, to get this next value here, I can see that my meniscus line is right in between. We've established that this tick mark is 36, and the one right above it is 37, right? That meniscus is in between. It is in between. So if I'm not up to the 37 yet, but I'm past the 36, I'm for sure I'm 36 and something else left over at the end. So these first two numbers I am sure of because the tick marks have told me that those must be true. So then I get out of tick mark region. In between that 36 and 37 line, I'm like, woo! Huh? That's where this last value comes in, this 4. Well, how the heck did she get 4? How does she know it is a 4? How does she know it is a 5? It could be kind of any of those things within some, level of just whatever makes sense. But that's an estimated digit at the end. So let's kind of mark this down. We said that our tick marks allowed us to write down with confidence numbers all the way up to that 6. We were sure it was 36 and something else and some change, right? So this is what we call the last measured digit. Okay? It was the one that we got because we were looking at the tick marks we were measuring. And so this is from tick marks. Yeah? And then I'm going to point to this 4. This 4 is super important. This 4 is an estimated digit. So we are going to write estimated digit. Yeah? And that estimated digit did not come from tick marks. It came from your brain right? So we're going to write from you. Okay. Now here's the deal. In order to measure precisely, you must measure this way every single time, okay? You must make an estimation digit one place outside of where the tick marks tell you what information you can gather. One place. You also cannot make more than one estimated digit. If you were like, great, 36.457, no, that is a wrong answer, okay? So this requires a little bit of practice because it is a little uncomfy at first, but it is super important in terms of representing our scientific measurements with that accuracy and precision. Now, down here, I want for you guys to look here. A lot of times we will discuss a measuring tool in terms of, oh, what is the precision of this measuring tool? The precision of a measuring tool is just what are the tick mark increments? So I always like to remind myself that when I see precision, I'm figuring out, well, what are the tick marks? We already established that the tick marks happen every 1 milliliter. So I would say the precision of this graduated cylinder is 1 millimeter. I also have represented down here what estimation value you need to make as a result of that precision of the instrument. And that is, like I said, one place past the tick marks. So that's where we fall into the 10th place. That's the 10th place, right? Oh my goodness, math, Sabatka, it's been a while. Okay, yeah. Okay, so let's do another example. This time with a ruler, we're gonna measure precisely. Oh man, that's hard to see. I'm gonna use a ruler on my picture of a ruler measuring thing just to kind of help me out a little bit. I feel like I always do a bad job of extending these lines. That was not terrible, right? That's not terrible. Okay, so what I got here is I got some tick marks. I'm sorry, it's super foggy to see. Hopefully it is better for your eyes on your paper. It's not much better, that's for sure. Okay, so I like to start with the actual numbers that I see. I'm like, cool, I see an 11 and I see a 12, right? So, oh, that gives me super confidence that I can knock out, 11. It's in between 11 and 12. There's going to be some fractions or change there at the end, and that's where I'm going to have to find my tick marks and what they're telling me. So it looks like first of all, there's a larger tick mark here. That's usually indicating where the halfway point is between the two bigger values that I'm measuring between the 11 and 12. So that's probably a 5, but just to check, let's see if we can. Looks like it may be going by ones. We'll check. 1, 2, 3, 4. Yep, that's a 5. And so 6, 7, 8, 9, 10. So once again, the precision of this instrument is every 10th of a centimeter, right? So that means I have to, with confidence, put a number there and be like, I am sure that number exists because of the precision of the instrument. Well, the number that we would put down is, it looks like that I don't even know what this object falls right in between that 6 tenths and 7 tenths. I can say with confidence that this next number has to be a 6, all right? Cool. Now I'm out of tick mark zone. That's fine. You have to estimate one digit further, but only one digit further, okay? So the next digit is coming from not the tick marks, but your brain. I think it's kind of like roughly like right in the middle there. That sounds pretty good to me. 5. Great. We love that. So once again, this is from your tick marks. We call that the last measured digit, and this is from you. So we had to estimate. Okay. Now, I have some real cute, real fun things that are super important. Down here you see a note at the bottom. It says, if your measured value falls exactly on a tick mark, which will happen sometimes, great. You still have to report an estimated digit right after it with a 0. And there's some examples that we'll get into here in a little bit later. But let's pretend that this object fell right on the 6 line, where you're like, yep, it's there. It's 6, I'm sure. You would still have to tell whoever it is that you're delivering this measurement to, who wants to know what the measurement how long this thing is. Well, to let you know, I'm sure it fell on that 6th line and there were tick marks to the 6th line, you would say 0.60. So that 0 represents the confidence in the representation that it is falling directly on that tick mark line. So that gets a little bit practicey. I told you this is a little bit weird of a topic, but you know, we like to be a little bit weird in chemistry. It makes things kind of fun. Okay, so now we're on the back page. The back page is going to go a little bit quicker. We're just going to dive into a little bit more on precision and tick marks and how that makes a good measuring tool or not. So since, like we talked about with my little kids' little thingies, like, oh my gosh, how funny. Since more markings or more tick marks on a measuring tool allow you to estimate more digits, instruments with the most markings that are spaced closely together are more precise instruments and therefore are going to be more preferred for measuring. So that example that I gave you with my 2 beakers, it was very easy to say, yeah, you're going to want to measure the 35 milliliters with the smaller one because you'll have more confidence. That is a more precise measuring tool. So over here, simple question, which piece of equipment would you rather use to measure out 30 milliliters of water with the greatest precision? You could probably just look at this and circle which one is the obvious answer, but let's be scientists here and, you know, look at the precision of each instrument. So I got a beaker here. Well, I see a 50 here, and I see a 100 here. So that must mean, like my beaker example that I just showed y'all, that I have a tick mark here in the middle. So once again, this is going to go 50, 75, 100. Starting at the bottom would be 0, 25 on that first tick mark. That's kind of hard to see, 50, etc. So my precision for this guy is 25 milliliters, right? All right, now let's look at my cute graduated cylinder. That's very difficult to see. I will zoom in. Well, I'm gonna make things much better. You're gonna have to trust me on this. So I see a 40 and I see a 50, and it looks like there are 10 tick marks in between that. So this is precision for every 1 milliliter, right? So I will zoom back out and say precision is 1 milliliter. So once again, when I'm measuring precision, that's tick marks. Tick marks. So this is tick marks. Okay. Wow. So which one is the more precise instrument? It is this one. Not because we're like, oh yeah, graduated cylinder is always the more precise instrument, because the tick marks tell me. Having a tick mark for every 1 milliliter is so much more precise than a tick mark for every 25 milliliters. Your answer, if you were to measure these two things, is going to be a lot more confident digits represented in the measurement than this one is, right? Okay, so in simple terms, more frequent tick marks is more precise. Got a couple more examples down here. Should be real quick and real easy and real fun for us to talk about. Okay. It says directions, measure the following according to the precision of each instrument. Finally, determine which instrument in the pair is the more precise measuring tool. We're going to start by measuring. So, luckily these volumes look like they are the same volume, right? But they're just in different graduated cylinders. I'm going to mess this up, so I'm going to move this down so I can get my head right on top of it, my eyeballs. Which is another thing that you do when you measure precisely. You need to actually move your head down to look at your measuring tool when it comes to volume, to where you are right there where that meniscus line is. Okay, that's pretty good. That's not bad. Okay, let's start with this weird one that I'm like, cool. Okay, well, don't got a lot going on here. I have a 4. I have a 5. So what is the first number that you have to write down? Is it a 2? Is this 2 milliliters? No, that would be way down there. Is it 6 milliliters? No, that would be way up here. I feel pretty confident that the first number is going to be 4. Is it exactly 4? No, because it's in between 4 and 5, but I'm sure it is 4 and something else, right? So, let's see. Next number. Let's keep cruising on through. Whoa, I'm already out of the tick marks. I have run out of tick marks. I now have to use my brain. So that is our only measured value here, but we still have to use our brain to make one and only one estimated digit. Now, I am not going to grade you guys hard on this. If I'm like, yeah, I think that's a 4.8, and you say, all right, on your paper a 4.7, that's fine. You know, we're human error here, right? What I'm looking for is I'm looking for something estimated here. within reason. I feel like I would maybe take off some points if you guys wrote 4.1 because, like, come on, you guys. So let's 4.8, we'll call it 4.8. But then do I go farther? No. I have to stop after I use my brain for one number. That is my estimated digit. And a lot of times when I'm kind of getting comfortable with measuring precisely and writing down my answers from a measured thing, I like to underline that cute little estimated digit because it makes me feel a little bit, okay, I did my duty. I didn't do any more than that. We're good. So you've written down 4.8 and you were ready to walk away. But this answer, although numerically is the correct value, would be counted completely wrong. I see 4.8 and I'm like, 4.8, what? Monkeys? Apples? And you're like, duh, no, milliliters. Well, not duh, no, you didn't tell me. You wrote a number down. So every measured value needs to come with units, and I will be taking off for that, units. Awesome. Okay, so that's our first guy. Now we got to measure that volume over here with this guy. Okay, once again, we see it's in between that 4 and 5 number that I can visualize. So we know it's got to be 4, right? Oh, but I got some tick marks here. Let's see what these tick marks are telling me. I got a tick mark for every 1 milliliter here. So my tick marks are going to give me this next value. I'm excited about that. So let's see. It looks like that's the 7 tick mark where it's mostly kind of either at or slightly above. We're going to kind of measure it both ways. Let's pretend that that is slightly above that 7 tick mark. Well, we can with confidence say that's a 4.7. Not a 4.2, not a 4.8, because it's not quite up there yet, right? But now I'm outside of tick marks. Got to estimate. I don't know. It's not that far above 7, so maybe we say 4.72. But I'd use my brain for that too. That's my estimated digit. I stop my measuring, writing down numbers there. Once again, I need milliliters at the end. Yes? Okay, so the second part of this question is determine which of the two is the more precise tool. Well, I mean, there's a couple ways you can do it. You're like, wow, way more frequent tick marks. The precision on this instrument is every 1 millimeter or milliliter. Every 0.1 milliliter, right? I'm not even going to write that on the bottom. That sounds good to me. So precision is every 0.1 milliliter, right? And over here, we add a tick mark for every 1 milliliter. So the precision here is that. Our more precise measuring instrument is going to be this one right here. So this one we're going to say is more precise. And I'm going to do exclamation point because that makes me happy. So precisely. Okay, next one we're going to measure some length. And they told me here that the rulers are in centimeters because this picture, it's like there's nothing to represent that. So that'll be important when we write down our final answers because I'm going to want to see units there. Okay, let's get my straight edge, which is also a ruler, which we love. Okay, actually, I'm going to come back up here real quick. I said I would do this. Let's pretend we think that measurement is exactly 4.7. Like we are like, yeah, it's right on the 7 line. You cannot just walk away. You have to, with your brain, even if your brain is just being like, yeah, I'm confident, you have to put in a 0 there. Does that make sense? And that one is very tricky for our brains, but just keep in mind if something falls directly on a tick mark, pop a 0 in there afterwards for that tick mark situation. Cute. Okay, now we're back down here to measuring. Back to the task at hand here. Let's start with this one. Woo, not a lot going on here. It's in between the 4 and a 5. So I'm pretty sure we got 4. Feel confident about that. Now I'm out of tick marks. I'm in the estimation zone. I have to use my brain. You got to write something down. 4.8 maybe? Yeah, that was my estimation. Only one place outside of the estimation. Stop writing numbers. And the units that I told you over here for these rulers are centimeters. Cool. All right. Next up, the bigger, it's not bigger, it's got more tick marks. So I'm already getting my brain being like, ooh, I bet that one's more precise. Let's see. So in between 4 and 5, again, the big ones. So I know that has to be a 4. Okay, now I've got, tick marks. It looks like we've got tick marks for every tenth, right? So that means I feel pretty confident that, oh, that's the 8th tick mark and that's the 9th. It's right in between the 8th and the 9th. So I have to feel with confidence that, yeah, it's 8, 4.8, and something else. But now I'm out of tick mark zone. So I got to use my brain. And my brain is like, I don't know, 3, 4.8. Could be 4. It could be whatever you think it is, as long as it's not something that just does not make any sense. I'm pretty happy to work with you on that kind of things. So maybe 4.83, right? But I have to have that estimated value that represents outside of tick marks. Do not walk away from this number. We need it to be in centimeters, right? Okay. So once again, after we've measured the two values, we've got to identify which is the more precise measurement, right? The precision of this top ruler up here is only 1 centimeter. And the precision of this ruler down here is 1/10 of a centimeter. So once again, that precision of 1 centimeter is represented by this last measured value before the estimation. And the precision of 1/10 of a centimeter down here is measured by this guy before my estimated digit. So my more precise ruler is going to be ruler number B. And we're actually going to continue this topic of measuring precisely with some more practice problems, with some lab activities, and to try to enforce those skills. But yeah, isn't that fun? Okay, so that was a lesson on measuring precisely and accuracy and precision.